Today we're going to be talking about two different comparison tests that we're going to be using to determine whether or not our series converge or diverge. So the first one is the direct comparison test, and this should look familiar from when we did improper integrals. There's a reason I do direct comparison test when we do improper integrals. And so you have a series that's smaller than a different series. So if the larger series converges, the one that's basically on top of this series, the smaller one, then we will converge. Now, if the smaller one diverges, that's going to force the one that we know something about to diverge. It's going to force the smaller one to diverge, I apologize. Okay, so our first example. Determine the convergence or divergence of this series. Okay, so we're going to compare it to. We are going to compare it to, think about when we were doing improper integrals. Take away anything that's kind of, quote, extraneous in the denominator. So I'm just going to look at, as we get really, really big, the plus one doesn't really matter. Okay, since this denominator is smaller, that makes the entire series, this denominator is bigger than the denominator where we're comparing to, okay, that makes that whole series smaller. So then you have to state something about the one that you're comparing it to. And remember, B of n is going to be something that we know something about. We know that this converges for, not for, I apologize, because it's geometric. And your ratio, which is equal to 1/2, is less than 1. Okay, so then you want to write me a little statement. Therefore, and remember you can use 3 dots for therefore. That means therefore, by the direct comparison test, the series that we want to know something about converges. Okay, so key things that you need to keep in mind. Okay, key things that you need to have. You need to have the comparison written out. Okay, then that one that you chose to compare it to, that's something you know something about. We know that that is geometric, so we know that that converges. And then therefore, by the direct comparison test, so naming the test. Okay, the next example. So our next example here. Again, kind of take away anything that's in the bottom. So I'm going to compare this to 1 over n. Now we know this is a smaller denominator, so it's going to be larger. So now I have a smaller series. Okay. What do we know about that smaller series? We know that this series diverges by the p-series test. Okay, because p was equal to 1. You could also say this is a harmonic series. Which also diverges. Okay, so the smaller one diverges. That's going to make the larger one also diverge. So by the direct comparison test, also diverges. So hopefully that looks familiar. And I always like the direct comparison test. Again, a few things you want to make sure you have. You have the inequality. You have the one that I picked, one that I knew something about, okay, whether that converges or diverges. And then by the direct comparison test, okay, what happens to the one that I didn't know something about? Okay, the limit comparison test. So the limit comparison test, both of my series have to be greater than 0. And if you find the limit of a sub n over b sub n, if that equals some limit, where the limit is finite, so it's some number and positive, then both of those series both either converge or diverge. Okay? Pick a sub n to be, a sub n is the series we know something about. B sub n is the one that I'm sorry, A sub n is the one we're given. B sub n is the one that we know something about. Okay, so you're always picking something that you know either converges or diverges. And then you just find the limit. And this is a little bit stronger of a test than the direct comparison test. I don't know why. I always get nervous on this test, and I always forget to use it. But this is actually a really good test to use. Okay, so determine the convergence and divergence of each series. So this first one, okay. So I'm going to compare this to, I'm going to use the series. Again, simplifying that denominator. I'm just going to use 2 to the n, okay? And we know that this converges because it's a geometric series. And our r, which is 1/2, is less than 1. So I now do the limit as n goes to infinity of the one that we are given over the one that we're comparing it to, which that simplifies to this. Okay, and what does that limit equal? Well, as you go to infinity, the 1 doesn't really even matter, so this goes to 1. Okay, so we've stated something about the one that we picked. Okay, we know that that converges, so now we can state that this converges by the limit comparison test. Okay. And the last example for this video. And you use the limit comparison test when you have something like a big polynomial on the top and a big polynomial on the bottom. That's why it's a little bit stronger of a form. So what you want to do is you want to look at the highest power on the top for what I'm picking, what I compare it to. The highest power on the top is 3 to the n. If I were to simplify out and multiply out the bottom, my highest power would be n squared, which that would simplify to 3 over n as we got to really big numbers. So we're going to compare to okay, and what do we know about the series? This series diverges because it's a harmonic, because that's a C, because it's a harmonic series. So now I do my limit. As n goes to infinity of 3n plus 2 over n plus 1 squared all over 3 over n. So simplifying that out, you have 3n plus 2 over n plus 1 squared times by n over 3. So if I were to simplify that all out and find my limit, that limit would be 1 because I'd have 3n squared on the top, I would have 3n squared on the bottom, okay? And something I didn't highlight, but this is finite and positive, okay? So the two series behave the same. So therefore, this diverges. So my series diverges by the limit comparison test. Okay? And again, making sure that you're stating which test you used. Okay? Make sure when you're comparing it to something, you know something about this series. So pick a series we know something about. Okay? And you pick that series by kind of simplifying out the numerator, simplifying out the denominator, and kind of reducing. That's how I look at it. Maybe it's not the best mathematical way to think about it, but that's how I look at it. Okay, I hope you enjoyed my video on the comparison tests.